Hey math kids, today we're going to talk about inverse trig functions, and to start we need to show how they're defined. So when I say inverse, we're talking about these things. So you can either see them, sometimes they'll be written as sine to the negative 1 of x, which means inverse of sine, or it will just be written as arc sine. Same thing with cosine and tangent, it'll just be cosine to the negative 1 or arc cosine. Okay, I'm not going to write the rest of them out. Now your book likes to use this notation, but I feel like I come across this a little bit more in the wild. But just know that they're interchangeable, they're the same thing. Now, when we're dealing with inverse functions, we have to do a domain restriction to make sure that the inverse is also a function. So for example, if we do sine and we reflect it across here, that's going to be going to look like that. And so if we don't restrict the domain, it's going to be a problem because it's failing the vertical line test in many places. Okay. So what we're going to do instead is we're going to draw a sine in a very specific way with a restricted domain that allows the inverse to also be a function. So if we only draw sine to the peak and then to this valley, so if we draw a sine like that, or in other words we draw it between pi halves and negative pi halves, so this is sine of x. When we take the inverse of that, we're going to get something that looks like this. Probably more like that. There we go. So the white one is the arc sine of x. Okay. Now what that's going to do is that's going to make our domain, the range, the same as the domain of the original. So that's going to be pi halves, negative pi halves. So if we're talking about range of sine, we're going to get negative pi halves is less than or equal to y is less than or equal to pi halves. Now, if we're talking about the domain, domain is going to be what the range was on the original function. So the range on the original function is negative 1 to 1. And so this is the same thing. We're going to get 1 to negative 1. So domain is negative 1 to 1. Okay, so that's for the sine function. Now, cosine. So if we're doing inverse cosine of x, arc cosine of x, we're going to draw our cosine function in a way. So we're actually going to draw it like this. Oops. So that's going to take us to pi and 0. And then the max and the min are still 1 and negative 1. So this, once again, is just for cosine x. Now, if we flip that across this line, we're going to get something that looks kind of like that. And the domain and range are going to be flipped because it's an inverse. So the white one is arc cosine. And so, since the y values were from -1 to 1, the x values are from -1 to 1. So the domain is going to be -1 is less than or equal to x is less than or equal to 1. And the range is going to be the same as the domain of the original, so 0 to pi. So it's going to go from 0, and then up here is going to be pi. So 0 is less than y is less than or equal to pi. Okay? And then tangent, so we can do tangent x, and we'll draw a tangent like this, which has asymptotes right here. This is pi halves. This is negative pi halves. And when we do the inverse, it's just going to look like kind of like this. And so what that leaves us with, we have a domain that's all real numbers, and then we have a range that's negative pi halves and pi halves. Okay, that was a lot of information to give you all at once, but the key is just kind of remember these domain and ranges. Okay? Alright, now let's try a problem. So we're going to say arctangent of x equals pi thirds. So the first thing is we want to check that our range works out. So the range for arctangent is negative pi halves is less than y is less than pi halves. I actually messed up on the previous screen. It's not equal to, it's, don't put the lines under it. On the previous screen, I think I put the lines under it. Okay, now, since pi thirds is in between these, we can move on. Now, once we know that we can move on, we're going to take the tangent of both sides, and we're going to end up with x is equal to tangent pi thirds. Then we can draw a unit circle. Pi thirds is our third tick mark, which has a value of 1/2 square root of 3 halves. Tangent is y over x, so we put our y value over our x value. We have the same denominators on the top and the bottom, and so our final answer is square root of 3. Okay, the next one is asking us for arc cosine of x minus 1 equals 2 pi thirds. Okay. Now, 2 pi thirds is within the range. So for arc cosine, our range is in between 0 and pi. 2 pi thirds is in between 0 and pi, so we can move on. So we draw our unit circle. This time we're going to have to estimate because it's not one of our 3 tick marks. And the way we estimate, this is 0, this is pi halves, which I'm going to estimate to 1.5. I just take 3 divided by 2. This is pi, which I'm going to estimate to 3. Then this is 3 pi halves, which I'm going to estimate to 4.5. Okay, if we estimate this as pi is just 3, that's really, the pi would cancel the 3 and it's a 2. So we know that we're in the second quadrant, somewhere right here. And we want to know exactly where we're at So what I'm going to do is subtract out 2 pi and see what's left over. So we have 2 pi thirds minus pi halves. We need to get common denominators. And so we're going to get 4 pi sixths minus 3 pi sixths. And that's just pi sixths. That's our first tick mark. So it's going to be our first tick mark here. That's symmetric with the third tick mark, which was the same point as this. But when we move it over here, it's negative 1/2 square root of 3 halves. Okay. Now, that's going to be helpful once we do some algebra over here. So let me make some room. So right here, if I do the cosine of both sides, these cancel. I'm left with x minus 1 is equal to 2 pi third, or whoops, equal to cosine of 2 pi thirds. Now cosine of 2 pi thirds, cosine is just the x value. Whoops, that's the y value. So it's negative 1/2. X minus 1 equals negative 1/2. We add 1 to both sides, and so x equals positive 1/2. Okay? And the last one that we're going to do is arc sine x equals 2 pi thirds. So the range is negative pi halves and pi halves. 2 pi thirds is on the outside of this. So 2 pi thirds is on the outside. We saw that with the, remember this is pi halves, and we saw that 2 pi thirds was right here. So we're only allowed to use arc sine if we're anywhere in this area, but since we're right here, we're outside of it, so we just say no solution. Okay, if you need additional help, please come to Math Lab. Until then, out.